Hello. Yes, we welcome you back to PSSB, Physical Sciences, Silver Bullet with me, Richard here. Yes, we are looking at this question today. It says that consider the pair of half cells below. Okay, we are having A, B, C, and T. And they say, for each pair, write the oxidation reaction or oxidation half reaction and the reduction reaction. Okay. So what do we do? Where do we go to start with this question? Okay. We start with, first of all, identifying which of the half cells anode and which one is cathode. So when you go to the table 4b, which is our preferred table, you have to know that whatever comes first is the anode, and what comes later is the cathode. Okay, so let us look at the first pair. We are looking at the pair between chlorine half cell and the chromium half cell. And which one comes first? Okay, when you check in the table 4b, it is chromium which comes first. So it's going to be here. And it is chlorine which comes later. Okay, so what does that mean? You have to remember that the reaction which takes place at anode is oxidation. Okay, and the one which takes place at cathode is reduction. So in other words, this chromium is the one which is going to undergo oxidation. And for this pair, it is the chlorine which will undergo reduction. So how do we write oxidation of chromium? We have to remember that oxidation is the increase in the oxidation number. So it's the change from solid to positive ions. So how do you write it? We are going to have the chromium here, undergoing oxidation to chromium ions. Okay. And the charge you have here is the one which reveals the number of electrons we need to use. How many electrons? 3. Which we put here. So this is the half reaction for oxidation. Okay. Yeah, then we come to the chlorine. What happens in the half cell of chlorine is reduction. A reduction is the decrease in oxidation number. Okay. So which one is decrease? Is it from gas to negative or from 0 to negative? Or from negative to 0. It is 0 to negative. So what are we going to have here? We are having our chlorine gas, okay, undergoing reduction to give you chloride ions. Okay, the first step here is to balance. So you put 2 there to balance. Next, after balancing, now we know the number of electrons involved. And it's 2 times this negative, which is going to be 2. So those are the electrons we put here. So this is it. This is the reduction reaction. And what we have here is the oxidation half reaction. Yeah, then we got the second pair, which is between silver and zinc. Okay, so which one is the anode, or which one comes first? You have to remember that whatever comes first here is the anode, and what comes later is the cathode. So which one comes first here? It is zinc. So zinc half cell will come here. And so silver comes here. You have to remember that the reaction which takes place at anode is oxidation. So it is the zinc which is going to undergo oxidation. So what does oxidation imply to zinc? Is increase in oxidation number. So it is going to be zinc solid, increasing its oxidation number to zinc ions. And this one tells us the number of electrons involved, which are 2. So that is the reaction. Okay. We know silver is going to undergo reduction. Reduction is decrease in oxidation number. What does that mean? That we are having silver ions changing into silver solid. How many electrons involved depends on the charge here. We have +1, so we have 1 electron involved. And where do we put it? We put it here. Here, those are the half cell reaction. This one for oxidation and this one for reduction. Yeah. So this one is done. Next is this pair between iron half cell and copper half cell. Okay. And which one comes first? You have to remember that whatever comes first is going to be our anode. And what comes later is going to be our cathode. And so which one is going to come first? From the table 4b, it is copper which comes first. So we have it here. It is Cu, CO2 plus. And the iron half cell comes later here. Okay. So what does that mean? It means that it's the copper which is going to undergo oxidation. Remember, the reaction which takes place at anode is oxidation. And what is oxidation? Increase in oxidation number. So what we are going to have here is going to be copper solid undergoing oxidation to copper 2 plus. This one tells us the number of electrons involved, which are going to be 2. So we put them here. Okay, for the reduction, what do we have? Reduction is decrease in oxidation number. We have a +3 here and a +2. Decrease means that we are going to change from +3, changing to +2. That's what we call reduction. And in this case, the number of electrons involved is the difference. So you have to know that how many electrons are involved here. The difference is 1, so we're going to have 1 electron, which we'll put here. Yeah, that is that. So what we have here is the oxidation half reaction, and this one is the reduction half reaction for that pair. Yeah, next is this last pair. Okay, we are supposed to write oxidation reaction and reduction reaction. Okay, yeah, like we did before, we are going to make use of our table 4b. Whatever comes first is the anode, and what comes later is the cathode. So between these two, which one comes first? It is the chlorine which comes first. So chlorine half cell is the anode, and the fluorine half cell is the cathode. Okay? And we need to know that the reaction which takes place at anode is oxidation. And the reaction which takes place at cathode is reduction. Okay. So for oxidation, this is what we are going to observe. And here we are having 0 and negative. You have to know that gases, solids, and liquids are having 0 oxidation state. So remember, oxidation is increase. So increase, is it from 0 to negative or negative to 0? Increase is negative to 0. So what does that mean? That we are going to have our chloride ion here, which are going to change to chlorine gas. To this stage, what do? We balance by putting 2 here. So the 2 tells us the number of electrons which are involved. So it's going to be 2 times negative. So there are 2 electrons which we put this side. So that is the oxidation half reaction. Then we come to reduction half reaction. What do? You need to know that this is 0, this is negative. So reduction, is it from 0 to negative or negative to 0? According to Cartesian plane, reduction is 0 to negative. That's decrease. So what are we going to have here? We are going to have fluorine gas changing into fluoride ions. At this stage, the first step is to balance by putting a 2 there. The 2 tells us the number of electrons involved. So there are 2 electrons which we put here. So what you observe here is the half reaction for reduction. Yeah, then comes this question. It says that for the pair C, okay, this is the pair we are referring to, write the net reaction. Okay, so what is the net reaction here? Okay, to accomplish this is what you have to know. You need to have the half reactions. And to have the half reactions, you need to identify which one is anode and which one is cathode. So when you go to the table 4b, the one which comes first is the anode. And this case, which one comes first? It's copper. So copper comes first, copper half cell. And the one which comes later is the cathode. So, which means that our iron half cell is here. Okay. So after that, what is next? Next is to have the half reactions. Okay. So the one for oxidation is copper. So it's going to be copper solid undergoing oxidation to copper 2 plus 2 electrons. Okay. Then the one for reduction is going to be this iron. I need to tell you that reduction is decrease in oxidation number. So decrease is from 3 to 2. So which means I'm writing iron 3 here. And the iron 3 is changing into iron 2. Okay. So from here, we can identify the difference. It tells us the number of electrons involved. How many are they? 1. And where do we put it? We put it here. Yeah. Then, the sum of these two, is going to give us the net reaction. But there is a challenge. When you observe the electrons, these are 2 electrons. This is 1 electron. And these electrons are supposed to cancel. So they have to be equal. What do? we multiply this second equation throughout by 2. So that electrons are 2. So you put a 2 here, you put a 2 here, and a 2 here. Okay? After that, what do we do? You cross out now your electrons. And what you remain with is going to form our net reaction. So we are having copper solid plus 2 iron 3 plus, giving you CO2 plus 2 iron 2 plus. Yeah, this is our net reaction. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yeah, we urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. So stay with us. See you next time. Bye-bye.